Welcome everyone. So today we will solve Leetcode problem 15, 3 sum. So we will be solving this problem using Golang. This problem states that we are given an array and we need to find all the possible triplets whose sum will be equal to 0. So if you look at examples, we can see that one such triplet is minus 1 and 2. So this is one result. Another such triplet is minus 1, 0, minus 1, 0, 1. So that is also another response. This also states that the result should not contain duplicate triplets. So this triplet should not come again, and one integer can only be used one time to form a triplet. So how to solve this problem? So we can see that we need to find triplets whose sum equals 0, right? So what we can do is it kind of hints us towards sorting the array, because that way we will know all the because that we will know all the smaller elements and all the larger elements, and we can easily identify by summing the smaller elements and the larger elements and checking if their sum equals 0. Now if the sum equals greater than 0, then that means we need to reduce our greater element, so we can move our end pointer towards left side. If our sum is less than 0, that means we need to increase our smaller element, so we can move our smaller element to the right side. So this kind of hints us towards sorting our array. Then after we have sorted the array, we need to find triplets. So for triplets we will maintain 3 pointers. All the 3 pointers will indicate 3 values inside the triplet, right? Similarly, like to sum, where we maintain 2 pointers, here since it requires triplets, so we'll maintain 3 pointers. So we'll begin with the first element of the array, then we'll point our second pointer to the second element, and we'll point our third pointer to the last element. And then we will keep on checking the values, all the values of the pointers equal 0. If suppose the values of the pointers equals greater than 0, then that means we need to reduce our third pointer. If our value is less than 0, then that means we need to increase our second pointer. And we'll keep on doing so until our second pointer and third pointer are not equal. And when we find a triplet, we'll increase our second pointer and we'll decrease our third pointer, right? And we'll also keep on increasing our first pointer when it is less than when there are values between these 2 pointers. When there are values exist between our first pointer and a second pointer, then we need to make sure that we also increase our first pointer so we can cover all the possible combination of triplets, right? So let's code this up and see how we'll solve it. So I'll first declare a response. It will be a 2D array of int. Now I'll check whether our length of nums is less than 3, because if it is less than 3, then we can't form any triplets. We will just return response as it is. Now I'll declare our first pointer. First pointer will point at 0, and I will check if our first point it will I will loop through the array until our first pointer is less than -2, less than of nums -2, right? Because we need to accommodate 2 more pointers after this, that's why. Now here I'll check if my first pointer is greater than 0 and nums I is equal to nums I minus 1. If it is, I want to increase the first pointer and I want to continue on the loop. Why I'm doing this? Because if my I lies here, right? And like first my I was here and then I increment my I to this point. And if this value is already equal to this value, then that means there is a chance that we will encounter duplicate triplets, which we want to avoid. That's why if I encounter equal values, I just continue. Now I will create my second pointer. My second pointer will be equal to I plus 1. My third pointer will be equal to length of nums minus 1. And then I'll check the value. First I'll loop through the array again until my second pointer is less than my third pointer. and I'll assign a value which will be equal to nums I plus nums j plus nums k. Now I'll check if my value is equal to 0, then that means we have found our pointer. We have found our one triplet, so I'll append rest with this triplet. So my triplet will be nums I, nums j, nums k. Else if my value is greater than 0, then that means I need to decrease my last pointer, else I need to increase my second pointer. Now when this loop is run, when our j and k values are no longer in this condition, then that means I need to increase my I pointer so I can loop through the rest of the array again. Now also one more thing, after doing this, I also need to increase my j, because when we have encountered a valid triplet, I want to increase j so we can encounter another set of valid triplets. Also, when we increase our j, there could be a case when the next value of j is equal to its previous value of j, and then in that case similarly we can encounter duplicate triplets. So we'll again do this for j is greater than 0 and nums j is equal to nums j minus 1. I'll do j plus plus. So this is just to avoid getting duplicate triplets. Now at the end of the array we will return this, and now we will run it. Also I need to make sure that I'll check here j is less than k, because I don't want our j to get greater than k, right? Because then it will invalidate this condition. Now I'll run it and see if it works. And okay, there is one error here. What's the error here? I'll just remove this because this will be valid always. Okay, so I increase my this, I decrease this. For j is less than k, I take the value. Now if a value is equal to 0, I'll append it. I'll increase j. I'll increase j again. If a value is greater than 0, I do this. Else I increase j. And at the end, I increase I. Okay. Mm. So, okay, my bad. We haven't even sorted the array yet. So we just need to sort the array first as well. So we will do sort dot ints dot sort nums and see if it works. I think it is sort dot ints. Yeah, I'll submit it now, and we can see it works and it's pretty efficient. This is all for today. I'll see you in next one.